try to say as much as possible the background to each question, so that you'll have an idea as to what the strategies are in solving problems of this nature. Okay, so things. Sorry, I'm still having a problem with this thing. Let me just get out of this and start all over again. Sorry about this. The first problem says the following. You've got a square, as you can see at the bottom right-hand corner. There are 16 little squares there, and the numbers from 1 to 16 are written in these 16 squares. No number is repeated. So it is also given that the 16, the very first sentence says the 16 is placed in the top left corner of this 4x4 table. So 16 is here. All right. Now, we don't know what the others are, but the question is, what is the sum of all the shaded squares? What is the sum, you'll see at the last sentence, of the 6 numbers in the shaded squares in the diagram? Right, so it's an interesting problem because you don't know what the numbers are, and how can we say what the sum is? But if you take the information that is given, the other extremely important fact is that in all the rows, 4 rows, the 4 columns, and the 2 diagonals, they all add up to the same number. They all add up to the same number. Okay, so we can calculate that number. That number is, because all the 16 numbers are repeated, the sum of the whole 16 numbers, the sum of all numbers, is 1 plus 2 plus 3 all the way up to 16. So you can add up all these numbers here, okay? And if you work that out, you get 136. Okay, I'm not going to go into detail with that. But now, that 136 is divided into 4 equal rows, for instance. So the sum in each row, what we call the constant sum. And this is the sum of the numbers in each of the 4 rows, and each of the 4 columns, and the 2 diagonals will have to be 136 divided by 4. Because 4 equal numbers adding up to 136. So the sum of all these numbers is 34, which means if this is 16 here, and all these numbers add up to 34, it means that if I'm going to put ticks here, those 3 numbers add up to this is 16 here. So those 3 numbers add to 18, and these 3 numbers also add up to 18, and those 3 numbers here also add up to 18. So we know those 3 add up to 18, those 3 add up to 18, those 3 add up to 18. So the ticks together with 16 add up to, we'll call the sum of the white squares, is equal to 16 plus, and you got 18 plus 18 plus 18. That's the sum of the white squares, and that gives you 70. So therefore, the sum of the black squares, or the shaded squares, the white squares and the shaded squares together add up to 136, we said. So all you have to do is to remove the sum of the white squares. That gives you the sum of the shaded squares. So the answer to this question is 66. All right. I'm sure that would not have been too difficult a problem. Let's just get on to the next one. Okay, we're gonna get to the next question. This question says, the sum of 2021 consecutive integers is 2021. The question is, what is the sum of the digits of the largest integer in the sequence? So you got 2021 consecutive integers, and what is the sum of the largest integer in all of these? Okay, so all we know is that they are consecutive for the starting point. Now there's a little background to this. How do you add consecutive numbers, or how do you add so many numbers? We don't even know how many numbers there are. And the way to do that is, so there is an important formula which is normally given at grade 10 onwards, and it deals with what we call arithmetic sequences. Now, consecutive numbers are like, for instance, we don't know what these numbers are, but we know when you add up the whole lot, you're going to get 2021. For instance, you got 6 and 7 maybe, and 8. These are consecutive numbers, right? And we don't know where it starts. Maybe it starts at some level, let's call it A, and it finishes off at some number L. L for the last one, and A for the first one, beginning of the alphabet, as it were. Right. So we don't know how many there are. Oh, no, there are 2021. So altogether, you got 2021 numbers like that. Right? And the sum of all this, when you add up all these things, let's call it S. If you call S the sum of this thing, so S is equal to A. A is the first term. So we should say right in the beginning, let A be the first term. We call them terms. If you got a sequence like this, you call these things terms, and L is the last term. Okay. So if you start with A, you got A, and the next one will be A plus 1, and the next one will be A plus 2, because they are consecutive, going all the way up to L. So there are quite a few, two unknowns here, right? And we know that this sum is 2021. This is what is given, right? The sum of these 2021 integers is this. So how are you going to calculate? This looks very complicated, but there's a very nice, clear, nice, neat trick that we use, especially when you have consecutive numbers and other numbers like this. You say that the same sum can be obtained if you write it backwards. So if you write this thing backwards, then you're starting with L, and the one just before L will be L minus 1, because they are consecutive, right? The one just before this will be L minus 1. The one just before that will be L minus 2, and so on. And you go write it backwards, and eventually you'll end up at A, right? So now why did we write it backwards? The reason is because when you add these two things, you get S plus S When you add these two numbers, you'll get A plus L. And here, when you add these two, 1 minus 1 is 0. So A plus L remains, right? And here, when you add these, you get A plus L plus 0. Again, you got A plus L. So interestingly, you got the same number, even at the end, you got the same number, right? Which is repeated 2021 times, because there are 2021 numbers altogether here. So if you got the same number repeated 2021 times, you got 2021 into A plus L. And this is 2S, which is 4042. Okay? So it means that the first term plus the last term is just 2. All right, this, now we don't know what there's also a formula for the last term. You see, if you look at this, the first term is A, the second term is A plus 1, the third term is A plus 2. So the last term, there are 2021 terms here. So the last term will be A plus 2020, right? Because the second term is A plus 1, third term is A plus 2. So the last term will be A plus, there are 2021 numbers altogether. So this L is actually equal to 2020. L is equal to A plus 2020. So, or if you like, you can say A is equal to, we need to find what the last term is. A is equal to 2020 minus L. So if you look at this thing here, I can write A as 2020. Um, I'm sorry, I've been just completely puzzled because of this bad thing. I'm really sorry about this. I cannot um, see what's going on here. Um, all right, let me just start all over again. I'm very sorry about this. Let's look at it differently. Because there's another way of doing this thing. If you got consecutive numbers, like for instance, say 5 plus 6 plus 7, right? We know that when you add these, you're going to get 18, which is the same as a middle number times 3, right? So the sum is equal to the middle number times times 3. So if you got 2021 numbers altogether, the middle number, right? Let's call it M. times the number of terms, which is 2021, is equal to the sum. And the sum is 2021. So the middle number is 1. So the middle number, if the middle number is 1, you got 2021 numbers altogether. So how many numbers do you have here? You got the same number of numbers on both sides. So you've got, if you work it out, you got 1010 here, 1010 here, because you'll have to take 2021, subtract 1 and divide by 2 to find out how many numbers there are here. And then you got 1010 numbers here. So you're starting from 1 here, and you're going all the way. You got 1010 numbers on this side. So you can see the very last number will have to be 1011. They're consecutive numbers, right? So the last number, L, is 1011. And the largest, the sum of the digits, this is the largest one, because they go all increasing, and the sum of the digits is 3. I'm very sorry that I took such a long time over this. I took the wrong pathway. You see, that's the thing about problem solving. You can try one method, it fails. You'll try another method, and you will see that it works. But unfortunately, I shouldn't be wasting time trying all these different methods here. But fortunately, we got to the answer. So just remember that when you're adding consecutive numbers like this, the sum is the middle number times the number of numbers. So I can calculate the middle number very quickly, right? And it turned out to be 1 itself. And then once you know the middle number, then you can work out what the last number is, because they are consecutive numbers. All right. Well, let's hope I survive the rest of this session. That wasn't very good, because I'm struggling with this mouse and it's causing a little bit of distress. I don't know what happened here. Some other problem here. Okay, let's get on to the next question. The next question is, we're going to question 3 now. P and Q are natural numbers such that P over Q is 7.25. Okay, in other words, you got a fraction. We don't know what the numerator is. We don't know what the denominator is. But the fraction simplifies to 7.25. If you write that in a proper way, you've got, this is 7 1/4. 0.25 is a quarter. And if you write it as an improper fraction, you've got 29 over 4. Right. Now, they say when P is divided by 2Q, now it looks as if P is equal to 29 and Q is 4. Right, so when P is divided by 2Q, so you divide 29 by 2Q, which is 8. The remainder is 10. But wait a minute, when you divide this, 8 goes into 29 3 times, and the remainder is 5. So what happened here? It looks as if there's something wrong with the question. Actually, there isn't, because you got 29 over 4. There are many ways in which you can write P over Q, right? If you think of equivalent fractions, this is the same as 58 over 8. You can multiply the numerator by any number, or you multiply the numerator by 3, and you have 87 over 12, and so on. There are many, many ways in which you can write this thing. So which particular form will work? Because when you divide 58, P could be 58, you see, and Q could be 8, in which case 2Q is 16, right? And then you will see that when you divide 58 by 16, 16 times 3 is 48, and there the remainder is 10, right? So this works, right? In other words, P is equal to 58, and Q is equal to 8. That's the one there, right? So what is the remainder when P is divided by Q, right? Now we know P is 58 and Q is 8. So when P is divided by Q, (58), when you divide it by 8 now, right, it's 7 times 8 plus 2. So the question is, what is the remainder? And it's divided by Q, and the answer is 2. Okay? So the important thing here is that equivalent fractions, there are many ways in which you can write a fraction. And in this particular case, you try all the ones and see which one actually gives you a remainder of 10. Fortunately, you come just to the second one, and the remainder is 10, and you stop there. Then you know what your P and the Q are. Okay? Right, so let's just get on to the next one. Okay, so now this is a story sum. Adam and Betty travel from Adam's house at the station to Betty's house. All right, now I always try to read the question, don't read the entire question. I just read it piece by piece and record the information. That's a nice way of doing things. All right, so I've got Adam and Betty, they're traveling from Adam's house at the station to Betty's house. Let's just draw this in the form of a little diagram like that and say that you are traveling from Adam's house. Let's call that A. This is Adam's house here. And then Betty's house is here. Right? And Betty's house is at the station. Adam's house is at the station. So here you've got a station. And this is Betty's house. All right. Now they travel from Adam's house, from the station, which is near the station, to Betty's house. Now Betty first takes a 30-minute train ride. So let's see. Betty, she travels firstly by train. Right? And it takes 30 minutes. But then walks. In other words, as far as Betty is concerned, Betty, she travels for 30 minutes by train, and then after that she walks. So she travels for 30 minutes by train, gets off somewhere, takes her 30 minutes here, and then she walks the remaining 1 kilometer. So there's a 1 kilometer here. It's the remaining part. At 5 kilometers per hour. So her speed is 5 kilometers per hour, and she only walks for 1 kilometer. So what does this mean? It means that in 1 hour, let's put it 60 minutes. In 60 minutes, she does 5. Or she can cover 5 kilometers. That is what you mean by 5 kilometers per hour. Right? Very important. 5 kilometers in 1 hour. That means if she walks for 1 hour, she will cover 5 kilometers. But now she only walks 1 kilometer. So how long does it take her to walk that 1 kilometer? It'll have to be 1/5 of this, which is 12. So she actually walks for 12 minutes. She walks for 12 minutes, right? So altogether, Betty walks for 42 minutes. See, I'm not even reading the rest of the question. I'm building up as I'm going along and trying to get as much information as possible, right? So that I understand the problem perfectly. So what I've just discovered here is that Betty takes 42 minutes to reach her house. The first part by train, 30 minutes, and the walk takes 12 minutes. Now, Adam travels by car, right? The road is 84 kilometers long from the station to Betty's house. So Adam now, the entire distance he travels is 84 kilometers. He travels by car from here to this, right? And he arrives at Betty's house at the same time as Betty. See, the last bit tells you that he arrives there at the same time as Betty. And we know Betty took 42 minutes. So therefore, Adam covers 84 kilometers. That's the distance he tells, but in 42 minutes, because both of them reached the house at the same time. Okay, in 42 minutes. So the question is, how fast does he travel in kilometers per hour? All right, so we have to convert this to hours, right? The 42 you have to convert to hours. So 42 minutes is, let me just create some space here. Sorry, I don't have much space on this. I can go to a whiteboard, but I want to keep track of the question so I know what I'm talking about. So let's just create this little space here. So you've got 80, he travels 84 kilometers in 42 minutes. So that's 42 over 60 hours. Now we want to know how far does he travel in 1 hour, kilometers per hour. This is 7 over 20. So he travels 84 kilometers in 7 over 20 hours. So in 1 hour, he'll travel 84 divided by 7 over 20, which is 20 over 7. So you have to multiply this by 20 over 7 to get 1 here. 20 over 7 will give you 1. That 7 goes into 84 12 times. So that is 7 over 10, I'm sorry. 6 goes into the 7 times, goes in 10. So it's 7 over 10. So that's 12 times 10. So it's 120 kilometers in 1 hour. That's kilometers per hour. Okay. Now, I've done this thing here in the long way to show you exactly what these things mean, kilometers per hour, and trying to understand the ratio. You see, if he tells 84 kilometers in 42 minutes, then you have to ask yourself in 60 minutes, how much does he travel? So you have to just multiply this thing by 60 over 42. That might be even easier. 60 over 42, and 42 goes into 84 2 times. So 2 times 60 can give you 120 straight away. All right. So that is the way to do it. But the other way is where you use the formula, the distance is equal to speed times time. And that is a very important formula that we have in these problems. The distance is equal to the speed that you're traveling multiplied by the time that it takes. See? Like if you're traveling at 40 kilometers per hour to Petermarisburg, right? That's your speed, and it takes you 2 hours. Then how far is it from Petermarisburg to Durban? Then it's distance, speed, times time will give you 80 kilometers. See, you can understand that without the formula, you can say in 1 hour he travels 40 kilometers. So in 2 hours, he would have traveled 80 kilometers. But the actual formula is sometimes it's useful to know that the speed multiplied by the time is the distance. Okay, so let's just get on to the next problem. Okay, I'll finish with that one. Now, in linear land, there are three currencies. There are gold coins, silver coins, and bronze coins. So there are three types of coins. Let's call them, what is it? Gold, G, bronze, B. It's nice to give names so that you can keep track. So you've got three types of coins, the gold, the bronze, and the silver, right? Now 7 silver coins and 2 bronze coins. Oh, wait, let's see. In the beginning, they say 2 gold coins plus 1 bronze coin is worth 3 silver coins. So let's just call this 2G, that's 2 gold coins, plus 1 bronze is equal to 3 silvers. All right, so you write that as the form of an equation. Right? In mathematics, when you a very powerful method of solving problem is to try to get equations. And once you get equations, then you can solve for them. Right? Because in school, you are taught how to solve for equations. But now in problem solving, you have to create your equation. So I've just created this equation using the information that was given. And now the second piece of information is that 7 silver coins plus 2 bronze coins is worth 5 gold coins. Right. Okay, so that gives you a second equation. See? So the question is now, what is 6 gold plus 5 silvers worth in bronze coins? So in other words, how many bronze? Right? Given this piece of information, 6 gold and 5 silvers, how many bronze would they make? Okay, so it seems to me that you'll have to find out G, 1 gold is how many bronze? 1 silver is how many bronze? If I know that, then I can calculate this. So I need to calculate what 1 gold is in terms of bronze and what 1 silver is in terms of bronze. So the way to do that is to get all the gold and the silver on one side. So if you look at these two and get the bronze on the other side. So the first equation becomes 2G. Now bring the silvers to one side, crossing the equation, and then you have bring the bronze to the other side. Right. So I want to get the gold and the silver in terms of bronze, right? I've got one equation, and the other equation, the second equation, the gold is 5G, right? And take the silver to the other side, you'll have minus 7S is equal to 2B. This, if you take it to the other side, the sign changes. On this side, it's 2B. So I'm writing it on the left-hand side. Otherwise, you can say 2B equals 5G minus 7S. But I want to write that, the G's and the S's on the left-hand side. So now, how do I find out how many G's there are? So the way to do this now is, this is 2 equations and 2 unknowns. And hopefully in school you have done this thing. And the way to do that is you have to eliminate the G's. So, right? And it gets rid of the G's. You got a 2 here, you got a 5 here. To get rid of the G's, you have to multiply this by 5 to get a 10 here, and multiply this by 2 to get a 10 here, and subtract, and the G's will disappear. So let's multiply the first one by 5 minus 10S equals minus 5B. You've got a negative sign here. So I've got the 10 here. I want to get a 10 in the second equation. So there you have to multiply this by 2 now. And then you multiply 7 by 2 equals, you multiply this by 2, you get 4B. right? So now you can get rid of the g's by subtracting. So when you subtract these two, what do you have? You have minus 10s minus plus 4s plus 14s. This cancels. Minus 10 plus 14, and here you have minus 4. What am I doing here? It's supposed to be 2g minus 3s. Yeah, 2g minus 3s. So I would have had uh, when you multiply this by 10, you got minus 30. All right, so I had the 2 here. So when we multiply this by 10, I should have had minus 30 here. 10 times 3, and this should have been 10b. Oh, I was actually multiplying by 5. I'm in a very bad shape here today. This thing has put me off because this mouse was not working. Mice are very troublesome creatures. They not only upset frightened women. Now you got 2g minus 3s equals this. So let's do this again. Multiply by 5. Minus 5b. And here you multiply this by 2. You get 4b. Right? Now when you subtract, this goes away. Minus 15 minus 14 gives you minus. There's a s here. Minus 15 plus 14 is minus s. And here you got minus 9. Minus 4 minus 9b. So s is equal to 9b. So we got s is equal to 9b. I'm not going to do the rest of it because I wasted too much of time. And then like that, now you can substitute s equals 9b into this one here, right? And I can just do it mentally, 9b, because so this becomes 27b, right? And then the 2g plus b is 27b. So 2g is 26b. So g is 13b. All right, you have to substitute this s equals 9b into one of those equations, and that will kill the s because s is gone. So you have only g's and b's, and you can work out what g is in terms of b. And once you got that, then the 6g, you can say 6 of these plus 5 of these, you can calculate it very quickly. The 6 of this will give you 78b, and 5 of the other one is 45b. So that gives you 123b. So 7 gold and 6 gold and 5 silvers gives you 143 bronze, 123 bronze. So that is the answer to that question. Okay, so it's a matter of writing down the equations, given the information, and then try to see what is the question, and that's very important. Because then you say, I must work out the gold in terms of the bronze. And to do that, the bronze have to come to the right-hand side, and the gold have to come to the left-hand side. And the same thing with the silvers. So the silvers and the gold going to the left-hand side. Then once you got that, then you've got 2 equations and 2 unknowns, and you can solve it using your high school methods to do that. Okay, now we move on to the next question. Hope I'm not missing out anything. Oh yeah, I am missing out something. All right, this one. How many positive 4-digit integers are there that are divisible by 5 with every digit even? All right, so you got 4-digit integers, right? So you're going to fill in 4 spaces. Let's just do it like this. So there are 4-digit numbers. They're divisible by 5. So it means a number is divisible by 5 means the last digit is either 5 or 0. So the last digit here is, this thing here is 5 or 0. Okay. But with every digit even, so this is out. The 0 is even. So the last digit is forced to be 5. There's only one possibility for the last digit. Now, the question is, how many of these numbers are there? But all the digits are even. So this number here, the first number can be 2, 4, 6, or 8. Those are the even numbers. Those are the possibilities for the first number. And for the second number, you see, 0 is also even, remember. So you could have had 0, 2, 4, 6, 8 here. You can't put 0 there because it's a 4-digit number. So the first digit can't be 0. But the second digit can be 0 because that's an even number. And the same thing here, right? So there are 4 ways of filling in the first number. I'm going to put that down. Now, this is not a 4-digit number, but there are 4 ways of filling in this. There are 5 ways of filling this. There are 5 ways of filling this. And there's 1 way of filling this because you can only put 5 here. You can put 5 different numbers. Now, knowing this, that there are 4 ways of doing the first one, 5 ways of doing the second one, and 5 ways of doing the third one, 1 way of doing the fourth one, how many have you got all together? Right? Now, to understand that, if you think of a situation like this, suppose you got, I like using this example here. Suppose you got, say, 5 ways. These dots represent towns, and these pathways represent roads. So you got A, B, and C are towns, and there are 5 roads that go from A to B, and 4 roads that go from B to C. So there are 5 ways of choosing this road, and 4 ways of choosing this road. And the question is, how many ways can you go from A to C? Right? If you think about that, you'll say, well, the first road can be chosen in 5 ways. And for this road here, I can finish off in 4 different ways. So for this road, I've got 4 ways. For this road, I got another 4 ways. For this road, I got another 4 ways, and so on. So this actually, you got 5 times 4. See? Because each is 4, it's 4 plus 4 plus 4, 5 times. So it's 5 times 4. So whenever you have a situation like this, if there are so many ways of doing one thing and so many ways of doing another thing, then the number of ways you can do both things together is you multiply both of them together. And that tells you that there are 20 ways of traveling from A to C. So in the same way here, the answer to this question here is there are 4 ways of choosing this, 5 ways of choosing the second one, 5 ways of choosing the third one, and 1 way of choosing the fourth one. And you multiply the whole thing, and you will get 100. Right? Yeah. I could have had, please, Madora Zungu, can you please put your speaker off? Thank you. See, if I had another town and another town, you can argue the same way, in which case you can multiply the whole lot. So that is the way to solve this problem, right? You find out how many ways of doing each thing and then multiply the whole lot. So whenever you see a problem like that, you must remember that that is a strategy. It's a very powerful way of counting. And you will come across questions like that in these problems. They like asking counting questions. All right. So the next one, in a quadrilateral ABCD, right? So you got a quadrilateral. So let me draw this quadrilateral. I'm not going to draw it to scale. I don't know what these numbers are. Okay. So the quadrilateral ABCD. When you're naming, always name in the same direction. And don't put A, B, and put a C here. You just keep going down from one vertex to the other. AB is equal to 6. AD is equal to 4. And BC is equal to 7. And CD is equal to 15. All right. So I've named all these sides here. And they say AC is a whole number. So AC that's AC. And the question is, we know it's a whole number. What is the length of AC? This looks like a very difficult problem because we don't know. You got 6 and 7 here, you got 4 and 15. And how do we know what this length is? All right, so this there's something that you have to use to solve this problem. And I'm going to tell you what this something is. If I asked you to draw a triangle, suppose I give you a problem like this. Draw a triangle having sides say 2, 4, and 8. Right? Now, you might want to say, let me draw the 8 first. Right? And then you're going to have one side is 2. So the other one is 2 units. If I call this BC, so the one side is 2. So let's say that this is 2 and this is 4. Now, if this is 2, that means this vertex is 2 units away from B. What does that mean? It means that it actually lies on a circle of radius 2. Because it's 2 units away from B. And in the other one, that thing is also 4 units away from C because you got 2, 4, and 8. Now you draw another circle of radius 4 now, and the point is on that circumference. Now you can see I've actually put them differently because if this is 4 and this is 2, you got less than 8, you see. So when I draw this circle and draw the circle, those circles don't cut. So there is no third point here. You can't draw a triangle like this. This is impossible to draw. And what made it impossible? What made it impossible was that 2 plus 4 cannot be smaller than 8. Because then you can't draw the triangle. You'll have 2. The point is 2 units from one and 4 units from the other. And the distance between them is 8. So that's impossible. So that allows us to say something very important, that in any triangle, the sum of 2 sides of the triangle 248 doesn't work because 2 plus 4 is smaller than 8. So we say, here's an important fact. The sum of two sides of a triangle is always greater than the third. Greater than the third side. If it's smaller, you can't draw it. So it means, like, for instance, now we don't know what this AC is. Let's call it X. Right? We have that 6 plus 7 is bigger than X. X plus 6 is bigger than 7. And so on. Any two sides, yeah, they're bigger. Like I'm going to take one particular thing. I'm going to say that X, this, is smaller than 6 plus 7, which is 13. Right? The sum of two sides of a triangle is greater than the third. So 13 is greater than X. It can't be equal, right? It must be greater than, strictly greater than. So your X is smaller than 13. And we are trying to calculate this X. But here now, you will have, I like to say that X plus 4 is bigger than 15. I could have said X is less than 4 plus 15, which is X is less than 19, but that doesn't give you any information because X is less than 13, and obviously it's also less than 19. So if I did the same thing here, I'm not going to get to any conclusion. But I can say this, that X plus 4 is greater than 15, which means that X is greater than, well, X plus 4 to be greater than 15, X must be greater than 11, right? So there you have it. You have this X is a whole number. It's smaller, it's greater than 11 and smaller than 13. There's only one whole number which is greater than 11 and smaller than 13. And the answer is 12. It's a nice problem, which uses the fact that the sum of two sides of a triangle is always greater than the third side. Okay? Now, this entire thing is going to be recorded. So in case you think, oh God, this prof is going so fast, I can't follow, you can get the recording. You'll be informed on how you can get the recording. It'll be on YouTube or somewhere. And you can go back and listen to this entire talk and come to this part here, slow it down and so on, so that you get a better understanding of this problem, in case you didn't pick it up in the first instance. All right, so let's just get on to the next one now. Okay. So now here it says, start with a small square of side length equal to 1. So let's just do that. Oh, this is not too small. Okay, it doesn't really matter. Right. Side length is equal to 1. So all the sides are 1. Now create a second square with the diagonal of the first square. So you draw the diagonal of the square here now. And you create a second square on top of this diagonal. Okay, so what happens is, sorry, I'm going to go into my questions here. So I create a new square on top of this diagonal, right? That's the second square. Now create a third square and use the diagonal of the second square to create the third square. So you create one more diagonal and create a third square on top of that, and so on. And so on. So you're going to keep doing this. Each time you draw a square, you get a diagonal. You draw a square on top of that, you get a diagonal. You get a square on top of that. And you can't draw it because there's too many. They say, which square will have the first square with an area of 2,020 square meters? That's a huge number, right? And we can't draw this thing because if you keep going on and go up to the squares are getting bigger and bigger. So the way to do this is, look, there's a pattern here. Each time I'm doing the same thing. So let me see, you want to get to a square whose area is greater than 2020. So I need to calculate the areas of all these squares, right? Now the first square I know is 1, 1. And what's the area of the second square? By Pythagoras, this is square root of 1 plus 1. So this is square root of 2. All right, so the hypotenuse is square root of 2, but the area of this new square is the square of the hypotenuse. So this area here is 2. Because the square of square root of 2 is 2, right? So the second square has got area 2, right? Now you can go and work out the area of the third square. Again, draw a diagram, draw a diagonal, draw the square, get the hypotenuse, and find that. And you can go on like this, but that is a very long and tedious process. But mathematics is very powerful. It tells you, you don't have to do it like that. Just see what the pattern is, right? What do you mean by that? Instead of taking this example only with this, let me take any one of these squares, wherever I am in this whole and I ask myself, if I know the area of one particular square, what is the area of the next square? That is really the question. Okay. So suppose I know the area of this square. Okay, we don't know. Let's just give it a name A. Right? So this area here is A squared. Original. We'll call it original. Area equals A squared. Now, what is the area of the next square? Well, again, we use Pythagoras. And here you have square root of A squared plus A squared, which is 2A squared. Right? So it's A squared plus A squared and the square root of that. That's Pythagoras' theorem. Square the two sides and find the square root of the sum. Now I got the hypotenuse to the square root of 2A squared. Right. So what is the area of the second square? Area of next square. It will be the square root of 2A squared. You square it. When you take a square root and square it, you're going to come back to the original. Right? That's what you mean by square root. Square root of 49 is 7. And if you take the square root of 49 and square it, you'll come back to 49. Okay, that's the thing about the square root. But now you see it's equal to twice the previous one. Twice previous. The area is twice 2 times the previous area. So in other words, each time you construct a square, the new square has got area twice the old square. And that conclusion we came to by just calling this A, giving it a random name, and then we observe that 2A squared, this A squared, so the area is twice that. So we're starting with a square at the first stage. First square is got area 1. The second square will have twice that, as we saw. The second square, we saw the area was 2. And the third square, it'll be 4. It's twice that previous area. and this is 8, and this is 16, 32. You can see it's getting bigger and bigger. I want to see when am I coming to 2020? 7, 64. The 8th one is 128. 9th one is 256. The 10th one is going quite fast. It's 512. 11th one is 1024. And then the next one is 2048. And that's the area which is greater than this. So the question is, which square will have the first square with area greater than that? It'll be the 12th one. The 11th one is 1024. And the 12th one is the 12th square because it's got area 2048. And that's the first one which has got area more than 2020. Right? Because after that, all the areas are still going to be bigger than 2020. But the very first one is the 12th one. That is the question. Okay. So now let me just get on to the next question. Okay. A cube is inscribed in a sphere of radius 1. What is the surface area of the cube? Okay, now we have to understand what this is. It's getting a little hard now. You got a cube and it's inside a sphere. You know, a sphere is like a ball. Cube because all the sides are equal. We don't know what the sides are equal to, but the sphere has got radius 1. In other words, there's a sphere which covers this entire cube. We can't see it. It's not easy to imagine. But what we do know is that this cube is inscribed in it. So all these vertices, there are 8 vertices in the cube, the whole lot of them are sitting on the sphere. Because it says the cube is inscribed in the sphere. So all the 8 vertices are sitting on the sphere. Now, I'd like to know what the middle of the sphere, what the center of the sphere is. Now, quite clearly, the center of the sphere will also be the center of the cube, right? Because this is all the sides are equal. So the center of the cube will be also the center of the sphere. So that's an important observation. The center of the cube is the same as the center of the sphere. Right. Now, where is the center? How are we going to find it? We don't know. To find the surface area of the cube, I need to find the area of each face, right? And then add all of them. So I don't, to find the area of each face, I need to know what the sides are. So I don't know what the side is. So that's an unknown now. If I know what the side is, then I can answer the problem, right? Okay, but let me see whether I can create an equation which involves A. Now this is the hard part, the tricky part. Okay, I'm going to imagine the center of this cube is directly under the center of that one. So let me just draw a line from here going to the center. So the center is here somewhere, right? It's directly under that one. Now, this line here is a vertical line. It's actually perpendicular to this line here. This line is on the top of the cube, and this one here is going from the center to the center here. So it will be perpendicular to this entire face, but it will be perpendicular in particular to this line which I have drawn. And the radius of the sphere is the distance from the center of the sphere to any point on the surface of the sphere. So this is the center of the sphere. Let's call it C, center. And to any point of the surface of the sphere, I just told you earlier on, there are 8 points on the surface of the sphere. Samuel, can you please put your mic off? Samuel, can you please put your mic off? Hello. David, I think you've got to just do something about Samuel.
Yes, I'm busy with that, Prof.
Yeah. Look, if people misbehave and they don't follow instructions, we'll take you out of the class. Sorry to say this, but we can't afford to waste time talking to people who don't follow instructions. All right, so we've got see, this is the center of the sphere, and this point is on the surface of the sphere. So then this line here has to be the radius. This is your radius, and it is equal to 1. It's given that the radius is 1. Okay, now you got a right angle triangle, and can we get an equation? Well, I'd rather, if I can call A to be the side here, but remember, this thing here is only half the distance from A. So let's call this thing here 2A so that I don't have any fractions. Let's say the side of the square is 2A. The reason why I'm calling it 2A is that this distance here is from the center to the middle of this, so that must be A, that distance. Right. So here you got 2A here, you got 2A here, and this one here is also, it's half the diagonal. It's right in the middle of the square. So this part here is a half of the diagonal of the top surface. But the top surface is a square. So the length of the diagonal of the square is square root of 2A all squared plus 2A all squared. So this length here is this, half the length of the diagonal. And the diagonal is the diagonal of the square. So you got 4A squared plus 4A squared is 8A squared. So it's a half square root of 8A squared. Right. So now we have the following. We've got this length here. You've got a right angle triangle. I know this. It's equal to this one here. I know that is A. So therefore, we can have an equation using Pythagoras. The square on the hypotenuse, which is 1, is equal to that squared, which is A squared. And you're going to square this. When you square this, the half is squared. And when you square that, you get 8A squared. Right? So when you take the square root and you square it, you come back to this. So what is this now? This is A squared. 4 goes into this 2 times. So it's plus 2A squared, and that gives you 3A squared. Right. So 3A squared is equal to 1. So therefore, A squared itself is 1/3. Right. We're still not there because the question is, what is the surface area of the cube? Now, the surface area of each face is 2A, 2A. That area is 4A squared. The area of a square is side squared. But there are 6 faces altogether. So the surface area is the total area of the 6 faces. So we are looking for 6 times 4 surface area is 6 times 4A squared, which is 24A squared. Right? And we just saw that A squared is 1/3. So 24 times 1/3 is 8. So the answer to this question is 8. The surface area of this cube is 8. Quite a deep problem, but it's a good try to understand this thing. Again, I said you can go back and listen to the recording. But the important thing is that I created a right angle triangle in this whole scenario. I identified what the radius is going to be. I said where the center is going to be. And then somehow I created a right angle triangle whose sides I know. Well, if I can calculate the sides. And then you use Pythagoras, and then you can calculate the side of your square. Okay, so that was a demanding problem. The next one, the containers A and B contain mixtures of red and green paint. I don't have too much of time. If some of you need to go away, I'll allow you to go. But I'm going to try to finish as much as I possibly can. Unfortunately, I started late. Okay, let's just have a look at this thing here and see. You got containers. So as we said before, it's always nice to draw these things. So let me draw a container, draw another container. And we're calling these A and B. So what do we know about these containers? It says that they contain a mixture of paint, red and green. So green and red are mixed up. I don't know what kind of color you will get when you mix up red and green. But anyway, you've got a red-green. We'll call this in red-green combination, paint. And the ratio of the red is to green is 3:1. So let me just not mix them up too soon. I'll just say that there are 3 parts of red to 1 part of green. So you got, let's just do it like this. You got 3, sorry. The 3 parts, 1 part, ratio, right? And in B, it's 5:1. Okay. All right, so far so good. Now, this is 6 liters of paint A. Now, this mixture here, you got 6 liters of that. Let's take 6 liters of this. And now it's a mixture of green and red. So you got 6 liters here altogether. Are mixed with X liters of paint in B. Okay, let's just see first how much of green and how much of red do you have in the 6 liters? The ratio is 3:1. So it will be 3/4 of 6. Which is green. I'm sorry, it's red, yeah. This is red, green. So you got 3/4 of that, which is 4.5 red and 1.5 green. So in this mixture, 6 liters, 4.5 of that contains red paint and 1.5 contains green paint. If you don't understand that, you can say, well, it can be 3x and 1x. So 3x, x, 3x plus x is 4x, and 4x is equal to 6. So therefore, x is 1.5, and that's what you got here. Right? And this is 3 times that, so 4.5. Okay. Now that is mixed up with X liters of paint in B. So what happens there is that if you look at the paint in B, you got X now. Altogether, you got X liters of paint in B. And we want to know the ratio of that is 5:1. So the question is now, if I've got X liters, the ratio of green to red to green is 5:1. So I've got X altogether, X liters. So 5:1, so it's 5/6 and 1/6. So you got 5x over 6, green, red at least, and x over 6, green. So you are mixing these two things up. Now you're putting that 6 liters and all this, and you're making one big potpourri of this, which is a rather messy business. And the question is now, I'm going to just put it in there. Let me see how much of green and how much of red there is in this mixture, right? So in this mixture, let me put red here and put green here. Oh, red, yeah. Oh, okay. It's supposed to be green here. Green and red. The ratio of green is to red is 5:1. I'm getting one mixed up here. It's supposed to be the green is to red. Red is to green is 3:1. Okay, that's fine here. This is fine. Red is to green. And yeah, okay, this is fine. Red is to green is 5:1. Okay, so now in this mixture here, these two things are mixed up. How much of green do you have? You got x over 6 plus 1.5 will make the 3/2. And then how much of red do you have? You have 5x over 6. They're all mixed up, you see. 4.5 is 9/2. So, and the question is now, the ratio of red to green in the resulting mixture is 4:1. So in other words, this 5x over 2 plus 9/2 over 5x over 6 over x over 6 plus 3/2. The ratio of red is to green, this over this, is equal to 4/1. So they say the ratio of the red is to green in the resulting mixture is 4:1. So here you have one equation involving x, and I'm not going to work it out. You can do it, but the idea in problem solving is to eventually get to an equation with your unknown. And your unknown was x, and I eventually got to the equation. Okay? All right, so I just want to check here. You see, how much of paint have you got here altogether? You got x over 6 plus 5/6. That is 6x over 6, which is x. And here you got 3 plus 9, which is 12/2, which is 6. So altogether you got x plus 6 in this mixture. Okay, that's perfectly in order because you had x of this was mixed with 6 of that. So altogether you'll have x plus 6. So this thing here gives you the entire mixture. That is equal to 4. Okay, and you can solve for that. I can't remember what the answer was, but I'm sure there was a nice round figure for the answer. Right. Okay, in case some people are still bothered about that, so we don't know how to work with all these fractions. Let me just quickly say, when you cross multiply that, you get 5x over 6 plus 9/2, that's the numerator, equals 4 times x over 6 plus 3/2, right? I don't like to work with fractions. And when I don't like to work with fractions, I multiply right throughout by some number so that what I call flatten the expression. Now I've got 6 and 2 here. I can multiply this entire thing by 6 and the fractions will go away. So if I multiply the left-hand side by 6, I have 6 times that. Multiply this by 6. 2 goes into 6 3 times, so you have 27. Multiply this by 6, and you will have 24 times x over 6. plus 3 over 2. Now this is okay. 24 times this is 4x. 6 goes into 24 4 times. And here you have 2 goes into 24 12 times, 36. So this gives you a very nice equation, and you can see that x is actually equal to 9. Right. I thought I'll just do that quickly to help you how to get rid of fractions. You multiply on both sides by a single number, which will get rid of the fractions. But make sure you multiply each term by that number. You must know how to multiply fractions to get to that. Okay, so that takes care of that problem. And where am I? Okay, this I'm not going to do. Okay, this is the last question. Those of you who want to go, you can go. But I'm glad to see there are still a large number of people. This is the last question. And just bear with me. Take me maybe just about 5 minutes. Now, Sophiso plays a gambling game. A fair coin is tossed 8 times. Now, what do you mean by fair? It means, it's heads will fall, tails will fall. You've got the same chance. It's not lopsided so that it gives a greater chance to head than to tails or whatever, right? They got an even chance. That's what you call a fair coin. It's tossed 8 times. And every time heads is obtained, half the amount that Sophiso has already at that point in time is added to that amount. All right. Now let's just try to put that in perspective. You got a coin, which is flicked, right? Right. So you have either heads or tails. Right. Now it says here that whenever heads appear, every time heads is obtained, half the amount that he already has at that point in time is added to that amount. So, in other words, if he had x, right, then that now is increased because x, half of x is added to that x. If he had x rands, then half of x is added to that. Now x plus half x is 1.5x, which is 3x over 2. So the idea is whenever heads fall, right, whatever he has, he multiplies it by 3 over 2. For heads, multiply by 3 over 2. And this is multiply to get the new amount he has. So, okay, now what happens to the tails? Every time a tail is obtained, he loses half the amount. So, in other words, if he had x here, right, then what happens is that he loses half that amount. He only, half of it goes away, so he only has half of it, right? So for tails, you multiply by half. Sorry, my writing is so bad here. I'm left-handed and it's not easy for me to write like this. So multiply by half. So each time you have a head, you multiply by 3 over 2. And each time you have a tail, you multiply by half. Okay. Now, what is the minimum number of heads required in order to make an overall profit? Now, that is quite a mouthful. Okay. Now, the question is, what is the minimum number of heads? So suppose there are he throws it 8 times, and suppose 8 of them are heads, x of them are heads. We don't know what this is. We'll try to understand the question just now. But it says, what is the minimum number? So that's an unknown. Right. Suppose there are x heads, and it's tossed 8 times. So therefore, there are 8 minus x tails, isn't it? It's either heads or tails. So he tosses this thing 8 times its heads, x times its heads, and 8 minus x times its tails. Okay. So what does he have altogether? Okay, we don't know what he started off with. So just imagine, suppose you started off with, an amount, let's call it, suppose you started with 8 rands. It's called A. Right, so there's A, starting point, first throw. We don't know whether it's a tail or a head, but let's put all the heads together. The X heads. So you have to multiply this by 3/2, right? And then the second one is a head again. So you multiply that by 3/2. Whatever you had, it's multiplied by 3/2. So it becomes 3/2 squared times A, you see, when you multiply that by 3/2. And the third throw, again, is a head. So it'll be, you multiply whatever you had by 3/2, and you come to this. But the X throws, right? So in other words, the third throw has got this, the X heads. So it's 3/2 to the power of X. Third row is 3/2 cubed times A. But now it has only tails. Right? Now it has tails. I'm putting all the heads together. So now the 8 minus X tails. So just like as you had here 3/2 to the power of X, because there were X heads, the same way you will have a half to the power of 8 minus X, because 8 minus X tails. So you keep multiplying a half 8 minus X times, because it's getting tails each time for the remaining part, right? Now, so you got, this is the amount he has after 8 throws. So it's, let's just put this in 3, simplify this. That's a messy business, right? And so what is the minimum number of heads required to show an overall profit? So this is what he has. To show a profit, it means that he will have to add more than what he started off with. See? So that's the part that needs to be, we have to think about it. To get a profit, whatever he had, he wants to get a profit. So you want to know how many heads must he create to do that? Must he have? All right, so I don't have space here, so let me try to simplify this. The A's cancel, you see. The A's cancel, but you got a strange unknown here. You got 3/2 to the power of X times a half to the power of 8 minus X. I'm canceling the A's. All right. Now, let's just, now this is 3 to the power of X over 2 to the power of X. And when you're doing indices, you do this. And you got a half to the power of 8 minus X. So if I invert this, half to the 8 minus X, right, is 1 to the power of 8 minus X over 2 to the power of 8 minus X. 1 to the power of 8 minus X. So now when you multiply these, this is greater than 1, you will have, the numerator is 3 to the power of X. 1 to any power is itself. But 2 to the X times 2 to the 8 minus X, this is indices, right, is 2 to the power of 8. You add the indices. So 2 to the power of 8 is greater than 1. Now 2 to the power of 8 you can actually calculate. So that gives you 3 to the power of X is greater than 2 to the power of 8, which is 256. right? Now you just try out various values of x, and you ask yourself, which is the first? It's a minimum, you see. So what is the first value of x, which will give you this? And you'll see that when x is equal to 5, it's 243, right? X equals 5, 3 to the x is 243, doesn't work. But when x is equal to 6, it works. So the minimum x is equal to 6. That's the first value of x for which this number is greater than that. So it's a matter of taking your information and go systematically and see what's going on here, understand the question, and then calculate it. Okay, this part here is a little bit tricky, but I'm saying put all the heads together and put all the tails together so it becomes easier to manage. And then you will see that you get some equation which you have studied in school, and eventually you can solve that problem. Okay, thank you very much for listening. And I know that just a small number of people have left. Thanks. And next week, we are going to tackle the problems which occur in the team questions. Right? You have already got those questions, and you can have a look at them and try to solve them. And you will see that they are quite difficult. But then what happens is 10 people get together and try to solve it. So everybody has an input, and somehow they will get, they can do much more than one person. So you don't have to be too afraid. Okay, those are team questions. Okay, thank you very much for listening. And I'm going to go into the chat group now to see if there's anybody who's got a question. Okay. All right, there doesn't seem to be any questions. I don't think you had any time to actually ask any questions. So